Hi, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to my lecturer. My name is Afiqah Hashim. So today I will present a project for electrical power technology of EET 208. My title is A Balanced Three-Phase System of Wire-Connected Circuit. Okay, for the introduction, nowadays the three-phase system serve as basic most electrical system, which consists of energy generation, transmission, and consumption. The single-phase system has only one wire phase and one return wire that it is used to for low power transmission. In general, three-phase systems are preferred over single-phase system for the transmission of power for many reasons. First, tiny conductor can be used to transmit the same kVA at same voltage. Second, the lighter line are easier to install and the supporting structure can be less massive and further apart. Most larger motors are three-phase because they are essentially self-starting and do not require a special design or additional starting circuitry. A three-phase system is balanced if a load of each phase has equal impedance value and a load impedance of each phase has equal phase angle, voltage, and current value are equal for each phase. In the case of balanced three-phase system, the current does not flow through a common neutral line. There are two possible configurations in three-phase system, which is wire connection and delta connection. The wire connection requires four wires in which there are three-phase conductor and one neutral conductor. In wire connection, the similar end of the three windings are connected to a common point called star or neutral point. The three-line conductor run from the remaining three free terminal called line conductor. The current flowing through each phase is called as phase current, and the current flowing through each line conductor is called as line current. Same goes to the voltage across each phase is known as phase voltage, and the voltage across two line conductor is known as line voltage. In electrical engineering, a wattmeter is a device used to measure the amount of electric power in watt. The two-wattmeter method is commonly used on three-phase load or circuit. Okay, for the objective, there are three objectives. First, to verify the circuit calculation for measure parameter of a balanced three-phase wire-connected circuit. Second, to determine the percentage of voltage drop in three-phase wire-connected transmission loss and load. Third, to analyze the active power absorbed by the load by using two-wattmeter method and the conventional measuring method. Next, we go to the methodology. Students are randomly assigned the line-to-line rate voltage of the generator. The connected transmission loss and load are given based on the message number. Then, student needs to find all the related parameters for phase current, phase voltage, and line voltage. In order to find the voltage drop percentage, the phase voltage at load must be calculated first. And the voltage drop percentage is measured by applying the formula V drop is equal to V supply minus V load over V supply times 100. And then calculate the active power absorbed by the load using two wattmeter method and the conventional measuring method. A balanced three-phase Y-Y connected circuit was constructed in PSIM software by applying a line voltage with frequency 50 Hz. Finally, we can run the simulation to measure all the related parameters in a balanced three-phase Y-Y connected circuit and record all data in table. So as I forgot, this is the three-phase Y-Y connected circuit that we have to draw. Okay, by applying the impedance value and the line to line that has given to us. The next result and discussion. Figure 5 shows the stimulation circuit on PSIM software. V line to line is equal to 11 kilovolt. In order to get the V phase, we need to use this formula. And my V phase is 6.351 kilovolt. Figure 6 shows the phase voltage on each phase A, B, and C. Since Z1 is equal to Z2 is equal to Z3, IN is equal to 0. So if we want to get the line current, we need to use this formula. So the line current and line current and the phase current is same. Figure 7 shows the line current on each branch of load. To find the voltage drop, we must calculate the V load first. So we use this formula to calculate the V load using the line current. And then since Z1 is equal to Z2 is equal to Z3, the V load is same. V load A, V load B, and V load C. They will get 4.132 kilovolt. Okay, figure 8 shows the phase voltage on each phase of load. Thus, our voltage drop for this system is 34.94%. Okay, so figure 9 show the active power absorbed by load. The active power absorbed by load using 2 wattmeter method. Okay. So the total power delivered to load is 624.633 kilowatt. And the conventional method, the active power consumed by the load by using this formula, they will get same as the wattmeter, 624.633 kilowatt. Okay, so this is data for line voltage to compare with between calculated and measured from the software. Data phase voltage, line current, phase voltage. Okay, table 5 shows the data for total power delivered to the load. And the calculated power that we get is 624.633 kilowatt. Measure power we get is 617.687 kilowatt. Okay, we go to discussion. Figure 5 shows the stimulation for balanced three-phase wire connected circuit in PC, and the phase voltage can be determined by formula BLL equal to Z3 time V phase. Figure 6 shows the stimulation result of three sinusoidal phase with 11 kilowatt peak value. Figure 7 shows the stimulation result for line current. Okay, we show this for figure 5, figure 6, and figure 7. Okay, continue this question. Okay. As we know, for three-phase wire connection, the line current is equal with phase current. From the observation, the value of voltage and current in the line and phase of the balanced three-phase wire connected circuit were measured and the results shown in Table 1, Table 2, Table 3, and Table 4. As shown before in this table. The value for all parameters that obtained from the calculation was slightly different compared to the measured value in PC simulation. Figure 9 shows the simulation result for the active power absorbed by load. The value of active power from calculation and simulation was almost same. The value of active power from the wattmeter method is 624.663 kilowatt, and the conventional method is 624.63 kilowatt, which is equally. While in stimulation, the active power is 617.687 kilowatt. When the load is balanced, thus the power delivered to each phase will be the same. Okay, so in addition, the value of voltage drop per percentage is 34.94%, which is exceed compared to the acceptable value drop plus minus 5% based on the standard British BS 7671. Maybe my voltage drop is not okay. Good. The last part is conclusion. As a conclusion, now we are familiar with local standard electrical system based on local electrical supply authority. Next, the circuit calculation for measure parameters of a balanced three-phase Y-connected circuit can be verified. We are able to determine the percentage of voltage drop in three-phase Y-connected transmission loss and load. Lastly, the active power absorbed by the load using two wattmeter method and the conventional measuring method can be analyzed. So, thank you. That's all from me. Bye.